What's up, savages? This is Vishu from SavageCamp, and today we are going to learn about hardlinks and softlinks. So, in the last lecture, we talked about files and we talked about a particular property of file called inodes. So, what are inodes? If I do an ls minus li, you will see a number over here which is called an inode, which is how the Linux kernel finds this file. So this file is located on inode number this. So if I do an echo on hello world and I put it inside a file called file1, and if I do an ls minus li, you will see a file1 with 12 bytes at this inode. So what are hardlinks and softlinks, and why are we talking about inodes? It's because when you create an hardlink using the command ln and you specify a name like hardlink, if I do an ls minus li, you will see these two files have the same inode. Now, what does this mean? This means both the file have one location, which means if I edit this file, so before editing this file, let's see what is in hardlink. So if I do cat on hardlink, you will see hello world, but we never wrote hello world into hardlink. We put hello world inside file1, which is at this inode. But when I do a cat on hardlink, it goes and checks this inode, which also has file1 because they share the same inode. So what it showed us is the contents of file1 because file1 also resides on the same inode. What this means is if I edit hardlink and I put this as SavageCamp and I save and quit. Now if I do a cat on file1, it will also show me this is SavageCamp. Why? Because we are not editing the file. We are actually editing the inode. When you write anything into this file, the changes are being saved at this inode. So when I cat on hardlink, you will see the same thing because both of them have the same inode. Now this is very important because if it looks like both of them are sharing 12 bytes, this is like very small size, but if there's like 1 gig of file and it has a hard link, that would be another 1 gig. Does that mean that they are using 2 gigabytes of your hard disk? No, because they are one file. They are being referenced by this inode. So no matter how many hard links there are, it still will have one inode, and that is the most important thing you should remember. Hard links are always referenced by inodes. That is how you find hard links. If I make changes into file1 and remove hello world, save and quit, I also made changes to hardlink because they share the same inodes. And this is the main important thing about inodes. If I remove hardlink, let me ls minus li. Now if I remove hardlink, what you should remember is this would not remove file1 because the file1 inode still exists. We removed a regular file which resided in the same inode. This is gone. You will see this is gone, but the inode for file1 still exists. So file1 is still there and file1 still has its data. Now this means that inodes are like directly connected with hard links. So what are soft links? So let me echo. This is a soft link example and put it in file2. Now ls minus li will give me an inode for file2. Now if I create a soft link using ln minus s, file2 and softlink, what it actually did is created a pointer. Now this is in a different color and this is in a different color. This created a pointer to file2. That is why it has a different inode. File2 has an inode ending in 490 and softlink has a inode ending in 940. Now that wasn't the case with hardlinks. Hardlinks had the same inode. Softlinks have different inodes, but it creates a pointer to a file2. And a pointer I can show you like this. It does not give me an option to remove the regular file. It gives me an option to remove symbolic link, which is a soft link. So if I edit soft link, it will show me this is a soft link example, changes made by soft link. If I save and quit and I do a cat on file 2, I will see the changes made by soft link over here, because when we are editing the soft link, we are not editing the inode. This is not a different file. This is a pointer to file 2. So when I edit soft link, file 2 is being edited. So if I go back to file 2 and I remove changes made by soft link and save and quit, now if I do a cat on soft link, you will see the changes are gone, because soft link is pointing to file 2 and we removed this changes made by soft link into file 2. So this is basically a pointer. So if I move soft link to /temp and if I do an ls-li on /temp, you will see it broke the link. Now what actually happened? What softlink is trying to do is find a pointer to file 2, but I did an ls-li on /temp, and if you notice, there is no file 2 over here. So it is not able to find file 2. That is why this is highlighted and softlink is in red, because we broke the link when we moved it somewhere else. Now let me move file 2 to /temp and let us check /temp right now. You will see the links are back. Why? Because softlink is a pointer to file 2 and it found file 2 inside /temp. So let me clear the screen. Now what happens if you lose this file 2? I'm going to do rm-f on /temp file 2. And now if I do an ls-li on /temp, file 2 is gone. You see that we broke the link again, because soft link is just a pointer. All it does is it points to file 2 and we deleted file 2. So it is not able to find file 2, so it is giving us an error. So if I do a touch on /temp file 2 and I do an ls-li, you will see the link back, because it found file 2. Even though file 2 is empty, it doesn't care. It is just a pointer trying to find file 2. So that is the basic difference between hard links and soft links. Hard links are connected to the same inode. So if you make changes in one hard link, it is going to be reflected in the second one, because you're actually changing the data in inode. But soft links are a pointer. So the soft link and the link it created to should be at the same location, and they are not referenced by inodes. They have different inodes, but the soft link we create is just a redirection to the original file. Let me know if you have any questions. It was quite difficult for me to understand this concept. So if you have any doubts, just comment below and I will try to explain it better.